Hello guys, welcome back to Life Technologies channel and thank you for watching. In today's video, we'll be focusing on how different OSPF features can be implemented on Huawei devices, and the main objective of the lab is to make you familiar with the OSPF feature configuration and troubleshooting on Huawei devices. We all know OSPF is a very common interior gateway protocol and is widely used in both carrier and enterprise networks. And then OSPF has so many unique features that help to improve network security and network convergence for a larger network. So our focus will be how to implement these OSPF features on Huawei routers. As you can see in our topology, we have set up a lab for implementing these OSPF features. We have different areas of running OSPF, and we also have an external network that is running SIS protocol. So, and the features we are aiming to implement are basic OSPF configuration, DR, BDR Election, OSPF Virtual Link, OSPF Authentication, Stub area, and then route import between the OSPF and SIS. So from our topology diagram, as you can see, we have different areas. We have area 0, which has router 1, router 3, router 10, and router 2. And then router 0 connects to area 1, which is a broadcast network. As you can see, we have a switch in the middle connecting router 11, 12, 13, and 10. Then we have area 2, which is also connected to area 0 via router 2. And we have router 5, which is now connecting to the external protocol, SIS, which is running between router 9 and router 5. We have area 3. Area 3 extends to area 4. Area 4 is not connected to area 0. So remember, that's where we need to implement the OSPF virtual link to ensure there is connectivity from area 0, our backbone area, to area 4. So this is the general setup of our lab, and let me jump into the lab objectives. So for our lab objectives, objective number 1 is to configure basic OSPF functionalities for different areas. We need to configure OSPF in area 0, area 1, area 2, area 3, and area 4, and ensure it's working okay. The neighbor relationship and adjacent is established. The routers can exchange LSAs and keep the neighbor relationship running. Then the next part is the next objective of our lab is to configure authentication for area 0. Remember, authentication helps to improve the network security. So we implement authentication for area 0. Then the third objective is to configure DR Election. The DR priority in area 0 to control DR and BDR Election. Remember, in a broadcast network, we are electing the DR and the BDR. And sometimes you need to control who is the DR and who is the BDR in our network. But in this lab, we only control who is the DR by changing the DR priority on the interface. Then, given that area 4 is not connected to the backbone area, we are implementing OSPF virtual link, so that we can have connectivity from the backbone to the remote area, which is not connected to the backbone network, area 0. Then to generate external LSAs in our OSPF network, we are configuring SIS on R5 and importing it to OSPF. Another OSPF feature that we will be implementing is the stub area, where we are controlling external LSAs from entering an area. So our area R1 will be configured as stub area. Apart from that, we have the general OSPF troubleshooting. Remember, when you are implementing OSPF, the neighbor relationship could fail to come up. So you need to know what to focus on when you are troubleshooting your OSPF status in a network. So you can see the topology. We are using ENSP for our simulations. You can see the area mappings and also the IP address assignments. We are using a /31 IPs for the point-to-point connection, as you can see in the topology. Then for loopback 0 IPs, the one that we'll be using as our router ID, remember it's a good practice to configure router IDs for OSPF. We are using /32 IP addresses and we are deriving it from the router name. For example, R1, it will be 1.1.1.1, R5 will be 5.5.5.5, R8 will be 8.8.8.8, following the same trend for all the other routers. So for the part of our configuration, we will not be configuring everything in the demonstration, but I've already configured the basic configuration of the routers, and our focus will be on how to implement the features that I've mentioned before. So for the basic configuration, our step 1 is to configure system names and interface IP addresses on all the routers. Remember, it's a good practice to always give your router a name based on the naming requirements by the organization. So I will just highlight router 1. Router 1, you have to enter the system view for you to be able to configure the configuration view for you to be able to configure Huawei devices. So the sys command, just enter the configuration view, and then we are giving it a name, sysname R1. So this is our router 1, so we call it R1. Then we are configuring the loopback interfaces. So it's just interface loopback 0. Then you give it an IP address of /32 subnet. Then our point-to-point interfaces, we also assign IP addresses as shown. So it's just you go under the interface and then you assign an IP address. So this has been done for all the routers, as you can see, and these are the configurations for all the other routers. And we can verify it on few routers by, let me just log into. So for example, R13, we can display IP interface brief. And you can see we have the loopback 0. It has been assigned an IP address of 13.13.13.13/32. Other interfaces will also have IP addresses. The Ethernet 0.0 has an IP address of 30.30.30.13/24. Remember, these are broadcast networks, so we are using a larger block of /24 in our area 1 as opposed to the /31 in others. So on R10, let me go to R1. On R1, I will undo terminal monitor, then display IP interface brief. You can see the interface IPs for 00, 001, and also the loopback IP address is assigned as 1.1.1.1. So these are the basic configurations for OSPF for the devices, I mean. So you have to configure the IP addresses and then you have to configure the system name in our step 1. Then in our step 2, we are now starting to configure OSPF in area 0, area 1, area 2, and area 3. Area 3 and area 4. So for OSPF configuration, they are simple. You just need to create an OSPF process which is locally significant on any router. So you give it OSPF 10. We are using process 10. Then we are assigning a route ID. Remember, route ID is the best practice to configure the route ID so that when you are troubleshooting your OSPF, you know if this route ID is down, you know this is the router you are talking of. For example, 1.1.1.1, we know it's router 1. 2.2.2.2, it's router 2. So you have to configure the router ID. It will help you when you are troubleshooting. So on router 1, we create a process 10. We assign it a router ID of 1.1.1. Then we have two areas. Remember, on our topology, router 1 is the ABR, the area border router between area 0 and area 3. So we have one connection going to area 3. We have one connection going to area 0. So we need to advertise these networks within the specific areas. And then loopback 0, we advertise it in area 0 also. So we have area 0 created. We advertise the two networks, loopback 0 and the point-to-point to R3. In area 3, we advertise the one network connecting to R3 to the other area, area 3. We do the same for other routers. Router 2, we are doing the same. You create the OSPF process, you give it a route ID, and then you are advertising the connected networks in the respective areas. In R4 is only in area 3, so we advertise the 3 networks within area 3. And the same process is used for the other routers, router 10, router 11, and router 12. So for example, router 12 is just an internal router within area 1. So we are just advertising the networks within that area. So once you've configured your OSPF, we can just log into some routers and verify that we have OSPF configured. You can display current configuration, OSPF. You can see our OSPF process 10 is configured on R3 and the networks are advertised. Then on R4, we can also check the OSPF configuration. OSPF, we have OSPF configured and we have the networks advertised in area 3. So I have already configured OSPF on all the routers in the different areas. So we have few commands that you can use to verify that your OSPF peering or your OSPF LSDB or status is okay. For example, you can display the OSPF peer brief to check the neighbors in a router or the adjacencies. You can display OSPF LSDB to check the link state database information learned by the router. OSPF interface to show which interfaces have OSPF running on them. Then you can also display the routes learned from OSPF, display OSPF route. So we'll verify this on few routers. On R3, we can display OSPF peer brief. You can see we have R3 is only in area 1, in area 0, the backbone area. So we have established peering with 3 routers, router 1, router 2, and router 10. You can see, given that you have configured the router ID, you can easily tell that this is our router 10, this is our router 2, this is our router 1. The state is full. Then you see the interfaces connecting the 2 routers. We can display OSPF peer brief. This one gives us more details. You see the area, the router ID, the address used to negotiate the peering, the DR and the BDR, the mode, whether it's slave or master, the priority. Then we also have the authentication sequence, then how long has the neighbor been up, the timers, the timer, how long it will take for the peering to tear down in case we haven't received any hello messages. You can see this one is the master for 10.10.10.2. So you can check all these details. So we can observe the same on router R12. Display OSPF peer. We have 3 peerings, and this one you can, it's in 2-way. Remember, this is a broadcast network, so if we have one router that is the DR other, it will only establish the 2-way relationship with other DR other routers, but you establish a full peering to the DR and the BDR. So on R2 will have one peering to area 0 and another peering to area 2. Display OSPF peer. You can see we have area 0, it has one peer, then we have area 2 with also one peer. We can display OSPF LSDB. So this one will have an LSDB for area 2 and another LSDB for area 0 as shown. And you can see we have the type 1 type 1 LSA, we have the network type 2, and we also have the type 3 LSAs for area 0, and for area 1 we have the same. We have for area 2 we have the type 1 LSA, we have type 2 LSA, and we also have the type 3 LSAs on this router. So this is how you can verify the OSPF peering status and also the LSDBs. If you display OSPF route, you can see the routes that you have learned from OSPF. You can also display IP routing table, and it will tell you that you are learning some routes from OSPF. The protocol is OSPF. So our OSPF is configured and is running okay. The next step is to configure ISIS on router R5 and R9, and we can also verify the status of that adjacency between R5 and R9. So for ISIS, this is how you configure. You define an ISIS process, which is also locally significant. Then you define level. Remember, we can have level 1, level 2, or level 1, 2. Cost style, you make it wide. Then you assign a network entity, which is very important when you are configuring ISIS. Then you give it an IS name. So when you are checking the relationship, it will tell you are peering to R5, and you can easily tell that my peer relationship is established with router 5. Then you have to enable the ISIS on an interface. So it's ISIS enable on that interface that you want to enable or run ISIS. R9 is still the same. So for verification, display ISIS peer, display ISIS interface, display ISIS route commands will help you to troubleshoot the ISIS status or verify the ISIS peering status and the route exchange for ISIS protocol. So we can display ISIS peer. You can see we are peering with R5. This is the interface, the circuit ID, the status is up, and the type is layer 2, the L2, level 2. Can display IP routing table. This will be direct, but on R5 we expect to have an ISIS route to loopback 0 of R9. As you can see, we have an ISIS route here, learned from R9, because on loopback 0 of R9 we are configuring and enabling ISIS, so it will be advertised to the other peer. So we've already configured our protocols, ISIS, OSPF, the interfaces, and the system name. Now we start implementing our OSPF features. The first OSPF feature we are going to implement is the virtual links. As you can see, area 4 doesn't have any connection to the backbone area. So for it to be able to communicate with other areas, we need to configure virtual link to connect it to area 0. So we are configuring a virtual link through area 3 so that we have a connection through the virtual link from area 4 to area 0. If you are to check the LSDB of R8, display OSPF LSDB, you realize it doesn't have any other LSAs learned from other areas. It doesn't have any LSA learned from area 3, no LSA learned from area 0, or even no LSA learned from area 1 or 2. So it doesn't have visibility of the other parts of the network. Even R3 will not have any information about routers in area 4. If we show IP routing table, we don't have any routes going to area 4. We don't have the loopback 0, we don't have the point-to-point. So we need to configure a virtual link from R6 to R1. Then we'll have visibility from area 4 to area 0, and also from area 0 we'll have visibility to area 4. And this is how you configure a virtual link. We are configuring it on R1, and it's also in area 3. Remember, it's in area 3 that we are creating the virtual link. So you just log in to R1, you enter area 10, and then OSPF process 10, area 3, and then you are configuring the virtual link to router 6. So this is not configured, so I have to configure it. I'll just copy, go to R1. We can paste. So we have configured the virtual links towards R6. We do the same on R6. So it is OSPF 10. Then we are pointing the virtual link to router 1, the loopback IP of router 1. So on R6, we do the same. We go into the system configuration view. I copied something wrong. Let me just display this to see the configuration. I have already area 0, then we have virtual link configured. So we have our virtual link between R6 and R1 configured. We can verify it by running display OSPF Verification. You can see our neighbor state is full. So it's just kind of another adjacency that we're establishing between R1 and R6. So you can see the virtual link neighbor ID 66, the one we have specified. The neighbor state is full, the interface, and the type is virtual. State is point to point, and it has a cost of 2. And we also have the timers configured. The transit area, we are transiting through area 3. On R6, we expect the same. Display OSPF virtual link, OSPF V-link, neighbor ID is 11, neighbor state is full, the interfaces, the type is virtual, and all the other details similar to what we have seen on R1. So now that we have a virtual link from R1 to R6, now our area 4 is connected to area 0. So if we recheck the LSDB, remember this was the LSDB before we implemented the virtual link. So if we check the LSDB again, display OSPF LSDB, you can see we are now learning external. We are now learning the summary LSS. We have router LSA, we have network LSA, we also have the type 3 LSS. But remember, before we didn't have any summary LSS. We only had router and network type 1 and type 2 LSS. But now that we have implemented the virtual link, we are getting the summary LSS coming from router 6, because now router 6 is acting as our ABR and advertising the type 3 LSS to us in area 4. So this is how you implement virtual links. Remember, the configuration is very simple. You just need to specify the virtual link peer and specify the loopback 0 of the far end. On the other side, you do the same. Virtual link, then the loopback 0 IP of the router you want to establish the virtual link with. So this is our first part, and we have finished implementing OSPF virtual link for area 4 to connect to area 0. Now the next part is to configure authentication. Remember, authentication helps to improve network security. No one will just come configure a router on your network and then the peering come up if it doesn't have the authentication key that is configured on the router. So this is a security measure for a larger network to ensure that you are protecting your network. So for authentication, we have different types of authentication on Huawei. For example, we can have, based on where you configure it, you can configure area authentication or you can configure interface authentication. When you configure both area and interface authentication, the interface authentication will take precedence. And you can either have plain or you can have MD5 authentication. So for example, if we were to take a packet capture on this R1 and just observe the hello packet that are being exchanged from R1 to R3, we will notice that we don't have any authentication on that link or in the area. But once we implement authentication, we will see that, yeah, now the authentication field has some value. So we just take hello packet, and then when you the OSPF header, you can see that the authentication type is null. We don't have authentication configured on this router or in this area, so the authentication type is set to null. But once we configure, we will have values here to confirm that our authentication is running. So even for other packet, the update, the acknowledge, we also don't have an authentication. But once you configure all the packets, we'll have authentication field set. So we'll do this configuration on R1, R2, R3, and R10, and we'll use MD5 authentication. But you can also use plain text, which is not secure, because remember, someone can sniff packets and observe that your password is a given string. So it's recommended to use MD5, which is more secure because it will be hashed. So we'll do this configuration on R1, R2, R3, and R10. So let me start with R1. I will quit from here. Just quit again, then paste the authentication. So we are configuring authentication modem device 1 and then cipher, and giving it Huawei 123. You have multiple options. For example, you can have the HMAC MD5, keychain MD5, or symbol. A symbol is not recommended. It will not be secure. It's like you can just see the password in the packet when you do packet capture. So always use MD5, which is more secure compared to the plain or the symbol text. So when you configure authentication, remember, when you are configuring authentication, you have to configure it on all the routers that are peering. If you just configure on one router, the peering will not come up with the other neighbor. So if you configure it on router 1, you definitely have to configure it on router 3. And router 10 has a peering from router 3 to router 10. But remember, we are using area authentication. So for any router in this area to establish a peer relationship with another router in this area, they should be having similar authentication mode and similar authentication key configured, or else the peering will not come up. So if you check R3, we have a peering to R1 has gone down. This is a very useful command. If you display OSPF error, we are able to see that we have bad authentication type configured, or bad authentication key, because we don't have authentication configured on R3 yet. So we have these packets increasing and reporting that, oh, we have bad authentication key or either bad authentication type configured, because on R3 the authentication is null. If we just run the command again, you will realize that the error packets are increasing on R3. So we need to do the configurations here, then our peering will be able to come up because we have the same key configured between the routers. So I will do the same on R2. And then on R10 in area 0. We are only doing it in area 0. So we have now configured OSPF peering, OSPF authentication, that is on all the 4 routers, R1, R3, R2, and R10. So we expect the peering should come up again, and then we should be able to see the authentication field set on the packet that we are capturing. So if you check on the hello packets, you can already see that for the OSPF header, we now have the authentication field set. Authentication type is set to cryptographic. We have authentication crypt key, and you can see it's hashed, so you are not able to see the plain text password. So this one verify that we have authentication configured on the router. And on R3, we can display OSPF peer. We will be able to see the same, that we have authentication sequence set, as opposed to before we didn't have this field, but currently we have the authentication sequence set to some number. So authentication will definitely help improve your network security, and it's a best practice to have authentication configured on your network. So this is our second feature, and we are moving to the third feature, where we have to configure the DR priorities in area 0 to force R10 to be selected as the DR. So remember, area 1 is a broadcast network. I have put a switch so that we can have a broadcast network for the 4 routers, R11, R12, R13, and R10. No configuration on the switch, just plug and play. So only do configuration on the routers. If we check R10 and display OSPF peer, in area 1, we have 3 peerings. Let me just check again. A display OSPF interface. So you realize I've already configured a DR priority of 10. I can remove the DR priority from R10 just to simulate. Interface big 0/0/3. Display this OSPF. So by default, I will shut down this switch and then bring it up just to force the peer relationship to establish again and see who is selected as the DR by default. So I will shut it down. So for Huawei routers or Huawei devices, for the DR elections, we have 2 criteria. The first criteria is based on the DR priority. By default, the DR priority is 1. So if you don't make any changes on the DR priority, every router or all the routers will have a DR priority of 1. So you need to have another criteria to determine who will be the DR and the BDR. So if the DR priority is the same, we now move to the second criteria, which is we are now comparing the IP addresses, and the router with the highest router ID will be selected as the DR router, and the second one will be the BDR. So remember, the DR priority is always set to 1 by default. So many times you have to change the DR priority on the router that you want to make it or to force it to be the DR. You can also do the same for the BDR. Maybe you configure slightly lower DR priority on the router that you want to be the BDR. So let's recheck the status. Display OSPF DR. It's still coming up. You wait for some few minutes for the peering to come up. you can see currently the DR and BDR is set to none, which means we are doing the DR and BDR election currently. So they are yet to elect with the DR and with the BDR. And now you can see in our broadcast network in area 1, we have elected router 13 as our DR. Why? Because it has a slightly higher, it has the highest router ID in the area 1. And the second router, which is router 12, has the second highest router ID, so is elected as the BDR. So 13 is our DR, 12 is our BDR. We can display OSPF peer. We expect the peering between 10 and 11 to be, where is router 11? To be stuck in the two-way. Remember, the DR other routers will not form a peering, full peering, so it's stuck to DR. The DR other routers will only form peering with the DR and the BDR. So we have, in this case, R10 and R11 are the DR others. So they don't establish OSPF adjacency. It's stuck in the two-way state. So on R10, we need to force it to be our DR. So it's 0/0/3. We do the same, OSPF DR priority, we give it maybe 10, which is higher than 1. So when there is a re-election, remember OSPF DR BDR is not preempted. Once the network is running and we have the DR and the BDR elected, it doesn't matter. You are coming, the new router in the network has which priority. It will not be elected as the DR unless a re-election process is done again. This is just to ensure there is stability in the network. So for us to force R10 to be elected as the DR, we need to just reset the OSPF process. But this one, it can never be done in the live network. So this is a lab and we are simulating the DR and BDR election. So we can shut down this switch again and verify that R10 will be elected as the DR. So I've shut it down. I expect the peering to go down. Display OSPF peer. It's down, so we can bring it up again and verify the DR status, DR BDR status. So given that we have configured a higher priority on R10, we expect it will now be elected as the DR. But sometimes it also depends on which router comes up first, which route establishes adjacency first. So in case there is a delay in OSPF adjacency establishment with R10, it will not be elected as the DR, and we may have to restart the switch again just to force it to come up faster and be elected as the DR based on the DR priority. So it's up. We can display OSPF peer. We're still waiting for the peering to start come up. So you can see, let's go back to this. Let's wait it to converge. So you can see currently our R13 was our DR, but now that this one has a higher priority, it has been elected as the DR. And then BDR is 11. Let's just confirm that it's already converged. So we have our DR elected already, and R10 has been elected as the DR. Why? Because it has a higher DR priority. So if we display OSPF interface, we can see the priority of 10. But the others, as you can see, for example, in area 0, we have priority of 1. So 1 by default, then 10 is the one we have configured. The higher the priority, the higher the probability of being elected as the DR. So this is the third feature that we have demonstrated, the DR and BDR election. The fourth feature that we will go through is how to import OSPF routes, SIS to OSPF, and verify that we are now getting external LSAs in other areas. Remember, in our network, we have different areas, and then we have router 5 is connecting to an external network. So if we are importing SIS to OSPF, we are generating external LSAs in our network. And this is simple, how to import SIS to OSPF. You just go under the process, OSPF process, and then you import route SIS 10. So I will run this on R5 and verify that we are having external routes. So on R5, but before I do that, let me just display the LSDB of R11 first so that we have a reference point. Display OSPF LSDB on R5. You can see we don't have any external LSAs on R11. We only have router, network, and summary network. And it's same for all the other routers. We don't have any external, but I choose R11 because we need to make it stub later and limit the number or the type of LSA that are coming into area 1. So on R5, I will do the import now. I've imported SIS to OSPF. You can do the reverse also, import OSPF to SIS if you want your routers in SIS to be able to reach OSPF. So you can do the reverse. So once I import SIS to OSPF on R2, if I display IP routing table, you can see now I have this type, the OSA route. The external routes are now coming in through SIS. We also have the loopback 0 of the other router. So we already have routes coming from SIS imported to OSPF. So if we recheck on R11, display OSPF LSDB, you can see we now have the external LSAs. And these one have been imported from the external network. So R5 is now acting as our SBR, connecting to an external network running SIS. And as you can see, we have external routes or external LSAs on our route 11. This was before. We don't have any external LSAs, but now that we have imported, we have external LSAs available, 2 of them. We can display IP routing table. We also have the OSA routes available on R11. So this is how simple it is to import routes between protocols. You just import SIS process 10. But remember, normally you have to use a route policy to control what kind of routes you need to import to OSPF. But here it's just simple. We are just importing all the SIS routes. But on a live network or a larger carrier network, you need to use our policy so that you are able to control which routes are imported to which protocol. So this is how you do route importation between OSPF and SIS. Now, the last part of our lab is to demonstrate how a stub area works on OSPF. So as you can see on R11, we are having external LSAs generated, advertised from R5. So And then you also have the summary SBR. Remember, this router has to know how to reach the SBR. So we have the type 4 and type 5 LSS coming in to give us the LSS that are generated from R5, which is the SBR. So, but in R1, we really don't need to get all those routes because we are connecting to R10. So all our traffic can be forwarded through R10. So we can avoid, or we can control the size of our LSDB by configuring, sorry, by configuring R11 or area 1 as a stub area, so that we only get type 1, type 2, and type 3 LSS. Remember, you can make it totally stubby and limit also type 3 and just inject the default route. But in this area, we just configure it as stub area. So when you are configuring an area as stub, you always have to run the stub command on all the routers. Then the peering relationship will be able to establish. You don't just run on one router and assume that your area is now stub. No, you have to run the stub command on all the areas. So this is how you configure. You enter the area. If for our case it's area 1, you run stub. Just the normal stub, not a variant of stub, the not so stubby or totally stubby. So I will do this on R13. So when I configure R13 as stub, the peering relationship with the other routers will go down. So I need to do the same for all the other routers. Then the peering relationship will reestablish. On R11, we do the same. We configure it as stub area. So we've configured our area as stub. We give it some time to converge. Once it has converged, we can now verify that we will not be able to get the external LSS in area 1, but we'll be able to get a default route from R10 in our routing table. So we can just verify on R11 again. It's still establishing display OSPF DR. The peering is up. Do we have the DR and BDR? Yes. If we display, remember when we display the OSPF LSDB up here, it is already, yeah, here. We display the OSPF LSDB before configuring it as a stub area. We had the external LSS, but now we have turned it into a stub area. OSPF LSDB. We need to give it some time to converge. Configuration OSPF stub on R10. We verify display current configuration OSPF. Our area 1 is stub. On R12, display this. It's also configured as stub. Then R13, display this. It's also configured as stub area. So on R11, let's check again. It will definitely take some time to so you can see we lost the I can't go back to the previous where we had the SBR LSA, SBR external LSA, because yeah, I cannot scroll past that. Let's check the display IP routing table again, and you can see we are now having the default route generated from router 10, which is our ABR. So we don't have external LSS, but we have a default route. And you can also configure it as totally stubby, so you will not get type 3 LSS, and you will only use the default route that is configured. So this is just a demonstration of these OSPF, the basic OSPF features. OSPF has many features, and for you to understand them, you need to simulate them. You need to troubleshoot, especially if you are preparing for an exam. You really need to simulate all these features. So yeah, we have simulated virtual link, we have also simulated OSPF authentication, we have done OSPF DR election, the stub area, route import, and also the basic OSPF troubleshooting that will come in handy when you are deploying OSPF in the network, or maybe you are preparing for an exam, either on Huawei, Cisco. Yeah, all these features need to be well understood. So this is the end of the lab, and the scripts and the lab is available. You can request for it and it will be shared to you, or you can visit our website. We have a similar article on our website giving the script and the step-by-step configuration. You can get the script from this website, and then you can be able to run the lab and be able to practice all these OSPF features in your own lab. So thank you for watching, and remember to subscribe for more content that we'll be posting on our YouTube channel, and leave your comments, tell us what you want to simulate, and we'll do the lab for you and share all the details to you. Thank you for watching again, and remember to subscribe to our YouTube channel. Thank you.